prove. So my suggestion is when you're doing proofs that the other thing is that you're going to need to use previous theorems many times to prove what they're talking about, in addition to the ones that are already in the sections. For example, if you look at this, I'll enlarge it a bit. If you look at this proof here, okay, it says, given that AC is congruent to DC. So here, what we're given, we're looking at the diagram, and we're seeing that those two segments are equal. So what I would probably going to do is mark that. So AC, this long segment here, this long segment AC right here, is congruent to DC, which means that these two blue segments are congruent to each other. And we're also given that one is up here, angle 1 is congruent to angle 2, okay? So we want to prove that triangle ACE, okay, is ACE, and E is this. Okay, let me remove here.
But I don't get how you find the
CE,
third
triangle
one.
ACE. Well, if you have ACE and you have DCB, right? What do they share in common? If you look at ACB and DCE, they have a common angle, right? So ACE is this here. So ACE, right? And DCB, right? They have a common angle there, and that's angle C. They have this angle common to both, right? So in that case, angle C, this angle here, is congruent to itself. So one thing you can do sometimes is split the diagram apart, and that might help you see it. But basically, ask yourself this question for this diagram. How many triangles do you see in there? This diagram here. How many triangles? Four? Okay, so there's a little one down here. There's a little one right here, right? There's this long triangle right here, which is ACE, right? But there's more than that. There's a triangle here. You see the bottom one right here? Yes. And there's another one over here. There's another one there. Okay. So my suggestion is, if you're not, I think part of what's happening is you're not focusing on the right triangle, the correct triangle there. But in this case, for the example that I'm looking at right here, triangle ACE, here's A, C, E, okay? That's this triangle, that's this one that's standing up right here, okay?
Other problems with one triangle, and I don't know if I'm supposed to take a side or take an angle. It's just coming.
You don't, okay, so you're not sure if it's the difference between a side and an angle? Well, a side is gonna have this segment mark. This is gonna have a segment mark if it's a side. If it's an angle, it's gonna have, it's gonna have this mark
But we have to find the third one. I don't
that
know
looks
what.
like a less than sign. That means angle. So side will, I'm sorry, repeat your question.
It's just one triangle.
If it's, well, do you have a, okay, let me see if I can find,
They don't have
what number are you, like this one here, like 27? You're breaking up. Let me see if I can, let me see if I can improve this a bit, because it's really hard for me to understand you. Your connection is, let me see if I can help myself a bit here. I'm gonna hook myself up to my hotspot for a second. Let me see. Give me a minute. Let me stop sharing this for a second. Grab this connection and see if it's any better. Okay, connect to you. I think see if that helps us. Okay, so you were saying, I apologize.
Yeah, 27. But I think I kind of get that one because I know that it has the bisect, and that
Right.
is a side that they share, right? And then
Right. PQ is the bisector, and they share. So you've got triangle MPQ and triangle QPN.
Yeah.
Right? Okay, so 27 was okay.
The 28, I don't know what that
What this symbol is, this one in the middle,
yeah, what is it supposed to mean?
that's perpendicular. PQ, so it's telling you that, okay, that's a good question. So here, this symbol here means perpendicular. So it's saying that PQ right here, this segment here, is perpendicular to MN. Now, perpendicular means that these two angles are going to be 90 degrees. Perpendicular means that it makes a 90-degree angle. So this is going to be 90 degrees, and so is this. Okay, so because those are perpendicular, and you know that angle 1 is congruent to angle 2, right?
Yes.
We have a theorem about angles that are perpendicular to each other. So here, this is, you'd start with the given. PQ is perpendicular to MN, and angle 1 is congruent to angle 2. So you were getting, now if PQ is perpendicular to MN, then you know that P angle PQM and angle PQN are 90 degrees
Mhm.
because that's the definition of perpendicular.
So would be
So
the side would be like PM and PN, or
PM, well, you could, you want to, oh, you mean okay, if you're going to use angle side angle, then you would use the fact that it's shared by both. Because it is still shared. MQP. So here, let me suggest that we do this for a minute. Let me suggest that when you do this, we're going to clear the drawing. Let's see. Let me clear it. What I'm going to suggest that you do is, all right, so I'm going to say, when you draw the picture here, so I'm going to draw this picture first. Something like this, right? And we have a line here. Now, this is not going to look totally to scale, but let me MQN. Okay, so this is going to be M here. This is M. This is Q. And this is N. Okay, and then P is up here. So here we have that. So now, if I'm doing the proof, if you're having trouble seeing it, I would break it apart. So in this case, I'm gonna do, oops. Where's the book here? So what it wants me to prove for 28 is that MQP, the triangle MQP, is congruent to NQP. So MQP is going to be okay. MQP, I'm gonna have to move this up. Give me a minute. Okay. So you can, if you choose, draw them separately. And I think maybe that will help you. So MQP, they're talking about this triangle here. This is M. This is Q. And this is P here, right? Now, MQP and NQP. So this is talking about this side. So I'm going to do this. I'm going to say that this is like this. Okay. So then I have, this is N here. So this is N. This is Q. and this is P, right? So then, now let's look at our proof again. So I'm going to come down here and I'm going to go to the book. And it says that PQ is perpendicular to MN, and angle 1 is congruent to angle 2. So they've given me that angle 1, which is this angle here, angle 1, which is the same as, and I mislabeled, let me change this. I mislabeled something. Let me fix that. So this should be, I have Q and P in the wrong place. This is P for this angle. So this is going to be, this is going to be P up here. My apologies. This is P and this is Q. So now angle 1 is MPQ. So that's going to be, they've given you this angle,
Yes.
and this angle are congruent to each other, right? They've also given you that MQ and this line are perpendicular. That makes this, because they're perpendicular to each other, that makes these angles 90 degrees by the definition of perpendicular, okay? So they've given you these two. So the easiest way to prove these two triangles congruent, you can do it a couple of different ways, but the easiest way is to say that they share PQ right here, as you mentioned earlier, and that PQ is congruent to itself, so that you can mark this. And so then you have an angle side angle relationship.
Oh, okay.
So that's how that proceeds. Now let me show you how the proof actually looks. So if you say, you always, when you have a proof, you start with the statements and the reasons. So here's your line. You have, we'll put some lines under here. Start with that many. If we need more, we'll add some. But we'll put statements on this side. Statements and reasons over here. Now, if we go back to the book, usually you always start a proof with at least one given statement. So we're going to start with segment PQ is perpendicular to MN. So here you're going to have, you're going to write segment PQ. So we're going to say, whoops, we're going to say, I lost my, there it is. Okay, I'm going to say this. Segment PQ is perpendicular to segment MN. And why? Because we were given that statement, right?
Mhm.
So then you write given on this side because they gave it to you. Now, as a consequence of that given statement, because they're perpendicular, you can say that we can go back and we can say that angle let's see. I have to look at the name of it. We can say that angle here. So we can say that angle so angle MQP, which is MQP, this vertex angle at the bottom, is congruent, or I'm sorry, is 90 degrees. And NQP is also 90 degrees by the definition of perpendicular, because that's what perpendicular means. So you can say that MQP and NQP are 90 degrees. So then you say that angle MQP, so this is MQP.
So there's always a 90-degree angle when you have the top part, I forgot what it's called.
This thing?
Yeah.
Yeah, this thing means this symbol, this thing that looks like a T that's upside down. This thing is called perpendicular. And perpendicular by definition means intersecting at 90 degrees. It means they cross at 90 degrees.
Mhm.
And we have a theorem that says that all right angles are congruent to each other. So angle MQP and angle NQP okay, angle NQP are right angles, right? Are right angles. And this is the definition of perpendicular. Here, definition of perpendicular. And then you can say that those two angles are congruent to each other. So we can say that angle, this is going to be angle MQP, MQP is congruent to angle NQP.
How did you get that?
How did I, okay, so how did I get which one? The first one or the second one?
The third one?
Okay, because we have a theorem. Hold on, let me show you. Let me go back. So this is let me go here to the book. And let me look for something here. Right angles are congruent. If you remember, this is another statement. All right angles are congruent to each other because they all measure 90 degrees. Okay, so all right angles are congruent to each other.
I don't think we
By,
did that section for homework.
okay, but the angles are out. Let's see if it's in the slides. Otherwise, I'm gonna have to bring I'm gonna have to look and see, because that's something that, let me see where they, give me a second. Let me see if I have the did you know that right angles were 90 degrees?
Yeah, and
Okay.
there's congruent angles.
So if they're all, okay, keep going.
No, they just have the same measure. That's what it says.
Yeah, that's the same thing as congruent.
Yeah, congruent.
So if all right angles have the same measure, then they're congruent to each other.
Oh yeah, that's
Congruent means that they have the same measure as each other.
yes.
Okay, so you did learn that. I don't know if it was in that section, but
It was the 1.4.
but it's there. Okay. Okay, I was starting to worry a little bit, but as long as, let me see if I have, is this the one? Or do I need, let me see which section this is. Yeah, this, okay, this is the one that okay, I started writing it, I didn't finish it. But I wrote the, let me see if I have another one. Hold on. Okay, I don't have that particular proof, but let me see. But yeah, so this is going to be, let me pull down the slides from this section and see if and see what it has on it. So let me go back one screen and I'll see what she used here. Because that's the thing, you have to use theorems from previous sections as well. So you'll have to keep those handy. So don't think that you're just going to use the theorems from the section that you're in. You're going to have to use other theorems from other sections. But let me see if I can find, yeah, this one is pretty similar. Okay, side, where's the proof that I want?
For the exam, is there like a review?
Yes, always.
Okay.
Always. She always posts the review at least a week before your exam.
I think it's on Thursday.
Well, the review, let me while I'm on the page, let me show you where your review is. Okay.
I think I found it.
And she posts the solutions as well. So usually the solutions are in the following module. So you're in, yeah, so here's 3.3 module 4 is quadrilateral. Your exam one is here. So if you look, here's under module 4, quadrilaterals, you have quiz 2, and then you have the solution to exam 1 review right here. And you can download that. And here's your exam 1 solutions. So you're gonna have true, false. You're gonna have some calculations with fill in the blank, and then you're also gonna have probably a couple of proofs or two to work on.
Is there charts I have to make? Oh, well.
Usually, yeah, see, so you're probably gonna have a proof like this, something similar to this one, okay? Yeah, anytime that there's proofs in the homework, there'll be proofs on the exam, but
Okay.
but that's how you come about doing it. So this is hers. This is her example proof that she gave you. And again, you can feel free to split the triangles apart if you can't see it. But she marked it for you. D is congruent to C. DE is congruent to EC. So here and here, right? Show that AE, this piece here, is congruent to BE here. So what she does is she shows that angle 1 is congruent to angle 2. First of all, and that's vertical angles. These angles are vertical. They share a vertex. They share a vertex at
Yes.
E. Okay, so generally the proofs that she makes you do are not the hardest proofs. They're usually pretty straightforward, but you go reason from the givens to something that you have a theorem for already, which is what we were doing here. If I come back to the proof that we were doing here, okay, you were given that these are perpendicular. You know by the definition of perpendicular that they are right angles, okay? And you also know from section 1.4 that therefore these are congruent to each other because all right angles are congruent, right?
Yes.
So now that you know that all right angles are congruent, meaning they have the same measure, right? Meaning that that's true. Now you can say, so now we're back here. Let me go to the diagram. You've got this angle given to you. You've shown that these angles have the same measure as each other. Now you can say that PQ right here, this middle piece, PQ, is congruent to itself, right? So this, as you said, that it was a middle segment before, a bisector. So you can say that PQ, so you'd need another statement down here. You need actually two. We need two more here. So we're gonna say statement number 3 here, or I guess number 4 would be that PQ is congruent to PQ because we have this is PQ is congruent to PQ. And the reason that we know that, that's probably from one of those early sections, is that it's the reflexive property, meaning that every segment, every angle, every ray is congruent to itself. Okay, so this is, you have PQ is congruent to itself. And so now you have, this is by the reflexive property. And therefore, you can say that now you've got two angles and a side between them, as I showed you here. Two angles and a side between them.
Mhm.
So now you can say that the triangle on the left is congruent to the triangle on the right by angle, side angle. Okay. So you can say that if we go back to the book, your last statement in a proof is always the thing that you're trying to prove. So the first statement is a given, and the last statement is what you're trying to prove. So what we were trying to prove here was that triangle MQP is congruent to triangle NQP. So we say that triangle MQP is congruent to triangle NQP. NQP and is congruent to triangle NQP by angle, side angle.
So whenever
So
you have a bisector, that's always a side.
not necessarily. A bisector just means that it divides another line in half. But when, let me see if I can answer your question this way. So here, okay, so that's your proof for, this is number 28. Okay. That's how the proof would look for that. Now, let me go here. Stop sharing this and share the book. Let me go here. Okay. So if, for example, so this part, okay, my screen share is loading. Here it comes. All right, there it is. So now this, let me take this off. This doesn't have to be a bisector for this to be a common side, okay? If it is a bisector, then it means that this side is congruent to this side. Okay, but I can share a side without this being a bisector, right? If
So what
I,
makes it a bisector?
what was that?
What makes it a bisector then?
They would have to tell you that.
Oh,
In 27, they told you that. But a bisector means that you're going to learn more about that later. But a bisector means that it divides the side that it crosses exactly in half.
okay.
So I could have, what I was going to show you is that here, for example, let me go to the whiteboard. If I draw, try to be a little bit more obvious. So if I draw, let's say, let me go black. Okay, let's do this. Here's a triangle, right? And whoops. And I do something like this. So there's a triangle, right?
Yes.
And if I draw, let's say I draw this here, okay? Now I think you can see that that's not a bisector, okay?
Mm.
That red line is not a bisector. However, if I label this, let's call this A, let's call this B up here, let's call this C over here, oops, C over here, and let's call this D on the bottom, right? There's C, and we'll call it D here. Okay, now, if I want to do something with triangle ABD, ABD as in David, then here, this is my triangle, ABD, right? This little one sitting, leaning on itself, right? It has a common side with CDB.
Yes.
Right? Now, whether this red line is a bisector or not, this side right here is congruent to itself. BD is congruent to itself no matter where it's sitting in the triangle. Okay. Now, I don't know that I'm going to be able to prove that these triangles are congruent because they aren't. But I can always say that the segment is congruent to itself.
Okay.
Regardless of what. Now, if it's a bisector, let me change this slightly. If it's a bisector, then I can say some additional things. And what I can say in addition to that, if it's a bisector, is that in this case, let me move D out of the way. Then by the definition of what it means to bisect something, which I think we looked at in chapter 2, right? A bisector means that it cuts it exactly in half. So if I'm given that BD is a bisector of AC, or that AC is bisected by BD, there's different ways they can say it. But if it's a bisector, then I know that D is exactly in the middle of AC. And so AD becomes congruent to DC by the definition of a bisector. But only if they tell you that. I can't assume that in the picture. Okay. Does that clarify?
Yes.
Yeah. Okay.
I had a question like on CPCT, like on 28.
Okay.
You don't put
Corresponding parts of congruent triangle. Sure. Let's look at that. 28. Let's take a look.
the problem with doing, we don't put it, right? Or we do?
I'm sorry.
Do we use CPCT on on the problem we were working on?
Not okay. On the one that we're working on, we used angle side angle. You can use corresponding parts of congruent triangles are congruent, but we're trying to prove the triangle congruent. We're not trying to show, you use corresponding parts. You use corresponding parts when you already have triangles congruent to each other.
Oh, okay.
So they're related to, let me stop this and let me go to the PowerPoint slides here. Is this the, no, this isn't the CP, is it? Let me check. I think that's 3.2. No, these are, you were asking me about, these are all about, 3.1 is all about angle, side angle, and side angle, side, and proving triangles congruent. CPCTC, which is corresponding parts of congruent triangles are congruent, is when you already have congruent triangles, okay? And you're trying to show that certain parts are congruent to each other. So let me go to that module and pick up the file. Let me pick up the modules for that. Oops, too far. Module, let's see. Okay, so let me share the screen here. Okay, so we're going to pick up the, yeah, you're talking about this here. Corresponding parts of congruent triangles 3.2. So this one, let me go back to that. There's corresponding parts. All right, so in this case, the difference here is that if we have proved that two triangles are congruent, she's using SAS, for example, but you could use any other theorem that works. Like we already proved that the two triangles that we were looking at were congruent by angle, side angle, right?
Mhm. Yes.
Then you can go back and you can reason back. Once you know that two triangles are congruent, you can look at their corresponding parts, is what this says, and say that the corresponding parts are the same.
So it has to be two triangles?
Yes, yes. So in this case, you would be given two triangles, corresponding parts of congruent triangles, plural, are congruent. So when you're dealing with angle, side, you're going from the parts and you're saying that the triangles are congruent. Okay, this theorem starts with congruent triangles and says, since the triangles are already congruent, the corresponding parts have to be congruent as well. So it's kind of the back. So here, okay, this is very similar to what, here's an example proof, okay? So you can see how this works. Given that WZ, this,
I don't see it.
you don't see it? Okay, let me share screen again and make sure that I'm sharing the slides. Okay, wait a minute. Let's see. How about this? How about now?
Yeah, I can see it now.
Yeah, okay. Given that WZ bisects angle TWV, okay, prove and that WT is congruent to WV, all right? Prove that TZ is congruent to VZ. So what are we saying here? This is saying that, here's what it's saying. Given that WZ, this segment, bisects angle, doesn't say it bisects the side. Okay, it says it bisects the angle, TWV. It bisects this angle here, okay? So that means this part, TWZ, not the triangle, but the angle up here, will equal the angle VWZ here, because it bisects the angle, okay? So we know that these two are congruent because that's the definition of an angle bisector, okay?
Yes.
And that WT right here is congruent to WV right here. Let's look at the proof on the next slide. So she says, all right, well, WZ bisects TW, they gave us that, right? And then angle TWZ is congruent. So that's talking about these angles that I marked for you up top. See, the bisector of an angle separates it into two congruent angles. This is the definition of an angle bisector, okay? WT is congruent to WV, that's given. So now you have the side here, right? And the
Yes.
side here, right? Now you want to show that this side at the bottom, TZ, is congruent to VZ, but before we can do that, we need to show that the triangle on the left here is congruent to the triangle on the right here, okay? So we're gonna do WZ, that shared side, that bisector, WZ is congruent to itself by identity, okay? She calls it the identity. You can also call it the reflexive property. Identity is fine too. And so therefore now look, triangle TWZ here, TWZ is congruent to VWZ here. Because look, we've got a side that's given to us. We've got the bisector congruent to itself, and we had that angle right in the middle that was given, right? So we've shown that the triangles are congruent by side, angle, side. So TWZ, the triangle TWZ here, is congruent to triangle VWZ here. And that means all of the corresponding parts are the same. So if we look at TW, which is the first two letters, that's a side of the triangle, TW and VW, they correspond to each other, okay, obviously, right?
Yeah.
Then we know that TZ, the first and third letter, TZ, which is this piece, which, okay, that's what we want. TZ is congruent to VZ or ZV. So that's by corresponding parts.
And it would be wrong if we use TZ and VZ instead of WZ as like a side.
Well, you can't use this last statement as a side because you're trying to prove that statement.
Okay.
This last statement is what we're trying to prove. You shouldn't use what you're trying to prove as part of the body of the proof, okay? Because you can't assume the truth of what you already know to be true,
All right.
okay? Does that clarify a little bit more?
Yeah, I get it now.
But the structure of a proof is always the same. Statements on the left, reasons on the right, okay? Start with something given. If you have more than one given, some people put all the givens first, but sometimes it's easier to split your givens and put them in logically where they would follow. But a proof always starts with at least one given statement, and it ends with whatever the statement is that you're trying to prove.
Mhm.
It always ends with that. So the statements in between it are the ones that you have to fill in.
Right. Okay.
Okay.
Yes. Got it. I'm gonna practice it.
Yeah, no, these proofs take practice. They do. But just keep in mind too that you're going to use statements and things that you knew from other parts of the chapters
Yeah.
in your proofs as you go along. Okay.
Got it.
Is class going a little better for you?
Yeah, the other homeworks I did pretty good. I explained them all. I worked it out.
That's good.
I just had problems with this chapter, like 3.2, because